Welcome back to our Scala to Spark class, and today we will look at the third major category of machine learning, which is unsupervised learning, namely segmentation or clustering tasks. So this is what we do when we don't have an answer, or maybe we have an answer, we might have an alternate approach. Instead of trying to categorize something, we try to categorize without knowing the answers. And we will look at the most popular segmentation or clustering algorithm, namely it's called K-means. So the answer is basically, the idea is you give it a number of partitions to be found, and the algorithm will find this number of partitions. Here you see an example how it actually works in practice. You have two features, right, and the algorithm basically divides this. K means 3. K is equal to 3 and it divides in 3 parts. Again, this is from Wikipedia. It shows what's actually happening. You don't have to follow the idea, but the basic idea is that it picks up 3 centers because it knows the K is 3, and it will go through and basically divide your data in these 3 partitions. They don't have to be exactly equal, not necessarily. Just it'll look for the most. It'll look for centers for each partition. It's kind of neat how it works. So, but there's only one downside to this algorithm. We'll see is that you probably can already think of what the downside is that you have to know the K. That's the only slight problem, right? How to find the K. But we'll talk about that, how to solve this, of course. But we'll start with the easiest example when we sort of know the K, right? So let's look at our, where's our, okay, let's open up our previous, open our recent Spark Summer right here. And we looked at regression, so we'll go back to working with, well, data when we have some, we want to find some answer. Basically, we have some data, we have some features, but we need to actually figure out divide it in some parts. We want to say, okay, maybe we want to check out outliers, maybe we want some other data. So again, where to find the answers? First of all, right, of course, the book mentions about this unsupervised learning, but also there's also documentation. Where's my documentation? Not here, not here. That's not it. Where is it? Yeah, here. Clustering, right? Basically, right here. Right. Clustering algorithms, right? On. So, most commonly clustering algorithms probably in the world, right? Again, Spark has done it, some optimizations for it. Again, it will work pretty quickly, right? But okay, but let's get the data first. Okay, so we'll use our friend irises. Remember, when we did some iris exercise, right? We will use something like that. We'll just get the data. So I will be, in order to save some type, right, I will get the data here, up to here, right? I won't divide it because, well, I don't have the answers. I'll pretend I don't have the answers, right? So here, right, I will use this example from day 35, and I will start a new file to save space. New Scala class, object, day 37 clustering. Add extends app, and we will check out clustering. Right. Yeah, we want those. Yeah, we want those. Right. Everything looks good. Right. So we load the CSV. We have iris type. Well, actually, I will show you. We don't really need the type, right? We don't need the category number, but we can keep it. Again, we won't really use it. We can see it since this is a case where we know the answers, right? We can check how well clustering works. Okay, but let's first see if everything is prepared. Is our prepared DF ready? Right. So we won't divide it. We won't divide. We will not divide in test, train, and test sets here, since we assume we have no categories at all, right? So we pretend we don't have this iris type. Actually, we don't have it, right? Let's run it. Let's run our day 37 clustering. And let's see. Okay, so we have it should be all ready now. Okay, that's our transformation. Okay, so data is ready. So basically all we really need is this, right? You need to have these features basically transformed into features, and then we would want to have it basically have the names here. By the way, let me show you something, a little trick. We could do it here, right? When we're loading, right? We could do here to df. We could change names immediately like this, right? There's a trick like this, column names. If you want the names, we can do, so for example, petal width, right? For example, petal height, right? Petal height, sepal width, right? On if you don't like or C1, C0, again, of course you could do it one by one, but we can multiply it. We can rename them here again, as in Spark has many ways of renaming and adjusting your data. And I'll say a type of flower category, category for example, right? So now if I do this, right, I don't need to do this, right? So that's df, right? I don't need to do this, right? Iris type, or I'll call it iris type, right? Iris type. I don't need this bit basically, right? Of course, I don't have it anymore, right? So I don't need it anymore, right? I don't need this anymore, right? Right? So, and then, of course, I can just do df, right? Df and df, right? Okay. And let's see how it happens, right? So basically, I added these names, right? I could rename it, I could rename immediately instead of using with column rename below, right? Again, just an alternative. Maybe you like this better. Again, alternative to show you just another alternative how to deal with column names. Okay, and again, our formula, of course, we could use, we could have used vector assembler instead, right? Since we do not need a specific, we don't need the category transform, right, to numeric, right? So, right, okay, but let's run it. Let's wait for it. Okay, as we can see, right, or top, so petal width, petal height, of course, this is just technical things, labels, again, maybe sample will be better, sample, sample 0.1, or 0.2, show, right, show, okay, because we won't see all, okay, but so, again, so we are going to use only this part here, right, to make a prediction, right, so, how do we do it? Very simple, right? We have a data. We are gonna import Kmeans, right? So we're gonna make a new model. So val km will be new Kmeans. And the only thing we need to set, of course, right? Since this is we're sort of cheating because we know the answer 3, right? We are sort of cheating since we know there are 3 types of irises, right? So that really makes our life easy here, right? Import class, there we go, ML, okay. And then the rest, as you can imagine, right, I can of course print ln, explain parameters. There's quite a few of those hyperparameters. There are quite a few to adjust, right? But what we can do is, of course, then we create a model, km model, right? And we fit, right? Km model will be km fit df, right? And again, by default, of course, default is, of course, set input features column, of course, will be features, right? Again, of course, this is actually default, right? And again, set output, set prediction column, we'll call it I think prediction is also the default, but again, just to make sure, right, you can control it. Again, also I think it's default. Also, I think also default, right? So, right, let's run it. So we have fit, and then we do, of course, we can do summary of the model, right? We can see cluster sizes, for example, and cluster centers, right? We can show that. We can get some summary. Again, usually summary equals K model, right? That's a K-means model, right? Of course, summary, and then we can do things like, for example, print line. What kind of cluster size? Cluster sizes, right? I think, yeah, print line, summary, cluster sizes. It's an array of longs, right? And this will be basically for each print line, right? Something like that. And also print line cluster centers, right? And we get something like K-means, K-model, or I think, yeah, K-model, cluster centers for each print line. So what kind of style, what type of data it is? Let's see. Let's check. I think it is array of vectors. Okay, we can print those, no problem, right? We could of course do maybe. We'll see how well it prints. I think vectors print pretty nicely. These are regular Scala vectors, I think, right? Okay, so that should give us some sort of idea of how it works, right? And of course, we can also, of course, well, let's run it first, right? And then we'll do, we'll make a prediction, of course, right? We will do, this might be, did I run it? Yeah, I run it. Okay, did it forget something? Features does not exist. How did that happen? Because df prepare, sorry, that's right, prepare df, of course, right? Features does not exist, of course, prepare df, right? Yep, of course, there, right? Because df did not have features. We did after transformation, right? Yeah, okay. Fitted df, yeah. And of course, we could of course skip this R formula, fit df and transform df, right? Also, we could do this in one line, of course, right? So, let's see what else. Yeah, let's run it one more time. On, it should come up. Okay, there are some features. Okay, so these are the centers. So their sizes 62, 50, 38. Again, maybe not perfect, right? But it worked pretty well, and it shows you where these are the feature centers for the each individual class. Thus, of course, these are represented by each. It's the things. There's 3 clusters. Well, why does it think there's 3 clusters? Because we said it. There should be 3 clusters. Okay. All right. So what else can we? Well, first of all, we can do, of course, prediction, right? Predicted df, and it is basically our KM model, right? Transform, right? And prepare df, right? Predicted. Okay, and that should give us nice answers, right? And again, I will do something like predicted maybe I'll do slice, you know, slice maybe, I don't know, 45 to 55, right? Oh, come on. Oh, date frame, sorry, not date frame, it's a date frame, you can't slice it. Select, we would like to, let's see, we would like to limit, maybe we could limit by ID, or we can do sample. Yeah, we can do sample, yeah, sample easiest, just sample. right? Maybe sample point 2, right? And again show false, right? Let's see what happens. That will transform, give us answers. Doing pretty good. We're doing pretty quick. Again, right, and there's a prediction. Of course, the model, the K-means model, has no idea how you are labeling, right? So prediction 1 and 0, you see they're reversed. That, of course, these don't have meaning, right? Meaning is here, right? So Aristotle, so basically, right, looks pretty good, right? 2, well, of 2 is actually, there's perfect match. Of course, you have just numbering system is reversed, but looks like there's almost no errors here. It's like said, you know, prediction 1, right? Same type of cluster, you know, whether what's the name of it is A or B or C or 0 or 1 or 7, right? Just different way of categorizing, basically. But yeah, it looks pretty good, right? So it looks like at least this sample looks almost perfect, right? Yeah, actually it looks perfect in this sample, right? But as we saw, it can be completely perfect because at least 12 are in the wrong category, right? Because you have 50 maybe perfect, right? Those nicely segmented, but 62 and 38, well, so those sizes didn't go as well because we already know there's 50, 50, 50. Of course, in real life, it's not that clear cut. As again, if you see irises, right, with these 4 features, well, some of those 2 types, so this is setosa and versicolor, they are kind of closely together, and these features are not enough to separate them. There will be always, no matter how smart your model is, there will always be few flowers, basically, who will be stuck together, right? So again, so that's nothing to be afraid of. Okay, so now we, of course, if you know 3, it works pretty well, right? Maybe not as well as supervised learning, but it does work pretty well. Okay, but what do you do if you don't know the answers? Well, there's something called how do you evaluate something? Well, is something called silhouette. So you want to do an evaluation on this, right? So it's using, I believe, you need a clustering evaluator, right? And it's using something called the Euclidean distance, right? Square Euclidean distance. Of course, what's Euclidean distance? You probably know from high school. Again, distance, basically you have x, y, you know, in a multi-dimensional space. You basically take a square root of sum of squares, right? Euclidean distance. You probably know what this is, right? Euclidean distance, right? Basically, that's a, you know, well, of course, this is for multi-dimensional space, right? But of course, in two-dimensional space, you have a, you know, where is the two-dimensional space, right? Yeah, you know, you have 2 points, and you basically take square root of these distance, right? Where it is, right? This is n-dimensional space, of course, right? You know, hyper-dimensional, but yeah. So that's how you do the evaluation. Again, it makes sense. It's a very basic evaluation method, right? So we create it here, right? Clustering evaluator. You could, of course, do it by hand. Again, I'll give you Euclidean distance. Use Euclidean distance evaluation by default, I believe, yeah. And now let's use it, right? So how do we use it? Basically, silhouette, right? We get the silhouette. Right, that's what we want, basically. And where's our predictions? Right, predictions, and we have predicted the F, right? And let's take a look. And let's run it. So this should be a, yeah, it's double number, right? That's a clustering evaluator, right? And this should give us nice double number, right? Basically, right? Something to basically. So this is what we use to evaluate how well the, so 0755, right? Okay, so you can now, let's see, let's test it again. Of course, we know here that our k means, we know that 3 is the right answer, but let's check how the score changes when we change the number of k, right? So let's make a little function. So let's make our little testing function of our own, right? And we'll do something like this: test k means, right? We want again k means, for example, right? We'll get def data frame, of course, right? And we want that, and k is gonna be our integer, right? Int, right? We can do int, right? Yeah, of course, k int. And we return the silhouette, right? Yeah, we'll get double, right? Again, we'll return the double, right? Okay. All right. Okay. You know, yeah. But we need to import data frame, right? Import. Okay, we are good, right? Functions written, but let's do it. So, testing or print line testing k means with k clusters, right? Something like that. And of course, we want to make a new method, right? So while we have made again 2 new means, right? We could of course use an existing one, right? But so we will do this, you know, set k, okay, right? Simple. Why not? Why not? And we don't even explain parameters. We don't what we want. We're gonna quit. We're gonna create a model. It's gonna be km fit df, right? We fit it. Do we want summary? Right. We could copy this summary here somewhere. Yeah, we could do this just for heck of it. Probably not very useful. Probably size. Summary centers I won't print, but the size might be useful, right? Right. And so this is km model. Yeah. Don't need, yeah, array of long for each print, right? Cluster sizes, okay. We could do just print line, comma, right? Cluster sizes, or maybe print line this, right? Print line, make string, you know, something like this, right? Okay. Okay, so our cluster sizes, but we want to get, most importantly, we want to return this, we have our evaluator. I wonder if we can use the same one. Well, let's make a new one. Why not? We can make a new one here, just to be safe, right? Of course, that's right, our evaluator, and we make our predictions. And we have predictions. We don't have predictions, right? We need our predictions, right? Predictions. BKM model transform ref, right? Fit and transform, right? And now we can return our silhouette, right? Yeah. And now we want to return it. So this is our silhouette. Okay. We return it because that's what we wanted it, right? Okay. Now we have a nice little tester. All we need is data frame. We can test it with this knowledge, right? And again, features, of course, you know, default features. Again, using features as default, of course, for input, you know, right? Okay, and right, you could of course test some other parameters here, and let's take a look how it works in practice. And let's run it. So let's do a loop, right? For like, again, let's try 2 to 8. See what happens, right? So 2 to 8, right? For each, no, map, can we map it actually? No. Let's check, let's see. We want to actually map, right? Yeah, we want to map. And it will be answer our silhouettes. Can't spell it, right? It will be array map. We'll do something like this, and right? Test Kmeans. Since we basically want to have a so this is going to be want a df, right? Was it predicted df? What kind of df use? Oh no, prediction. Sorry, you see that's very careful here. You see, very careful. Don't use the internal, right? That's a good thing we had a gray number, because otherwise we were using the other one, right? And our predictions would be same. Our silhouette score would be also the same, then, right? So probably better to just get rid of this previous code. So data frame comes in, and we are using prepare df, right? Prepare df and we use n, right? Okay. What's going to be what sequence? Index sequence of double. Okay, right? And then can we print it, right? So we now, of course, print basically or silhouettes, right? Of course, 1 doesn't make sense, right? Maybe 10. So print line or silhouette scores. Right, segments. Right, so that happens when we do segmentation in, you know, from 2 to 8 segments. So we divide. So we check our silhouette score from 2 to 8 divisions. Right. Again, of course. Well, thing is, okay, you might be asking, what's the best K? Well, think about this. If you do 150, right, this will be perfect score, right? So that doesn't, but that's kind of useless, right? You have 150 units, you divide 150 divisions. That's really, there are no segments. Everybody is alone, right? That's not really good, right? Again, right? Okay. Again, remember. I mean, of course, our best silhouette score would be with 150 segments, since we have 150 rows, but that would be useless, right? So we'll talk about how to interpret this data, right? So silhouettes, yeah, index sequence, print line. I think I can just basically print line. Make string. Yeah, I can do that. Okay, let's take a look. See how it works. That's index sequence. You can do, of course, to array if you want, right? Let's run it. Right, you can see the tilde scores here, right? And yes, so we can see actually, yes, right. Okay, this is actually a pretty good example, right? So this actually comes, how do we determine what's the best, how do we use something called, how do we decide this number? So we use something called elbow rule. Elbow rule is pretty famous, right? In machine learning, right? Right, in clustering, right? Number of clusters, percent chance. So basically, when it starts, you go back for silhouette, right? Here it goes down, right? Cutoff point, right? So elbow method, right? And this is using number of clusters, percent of variance explained, basically, right? So here, right? We go down, right? So again, it might not be completely sharp, but basically when it becomes, the growth becomes, you know, not so sharp, basically. Again, it's sort of not a hard and fast rule, but you can see here it sort of gets slows down, right? So questions, can you tell here from this data, right? Using silhouette, right? So silhouette score, elbow silhouette score. Let's again. So silhouette right? Right. And believe it's actually here in Scala, right? So 87, actually pretty recent score, right? I believe Kmeans so -1, so high value, yeah, poorly, okay. So, right. So what's interesting actually from, yeah, then if many points have low or negative value, then the clustering configuration may have too many or too few clusters. So it's interesting here. It didn't really help too much, did it? So it thinks, well, so here, right, we can't really tell here in this case, right, 2 would also be pretty even better, right? So clustering in 2, if you didn't know that there are actually 3 types of flowers, right, if somebody didn't tell us, we would only have 2 clusters. So in this case, 2 clusters would be the best answer. Highest score is actually 2, right? So of course 1 would be kind of pointless, right? Same as goes for 150. At some point it will start growing, but again you see that, well, so 3 actually is a good answer, but 4 also, you could drop in 4 also, you will not get. So in this case you can't really use this to determine the best number of clusters, right? Again, you would think 2 is good enough, right? But okay, so this will be a good challenge for you, knowing this, right? Let's see how much time we have. Right, we have some time. Actually, let's talk about what else does the chapter talks about, right? So, right, it's usually used for anomalies. Like again, you have some big groups and small groups. You can check data, right? Also for topic modeling is good, right? So, again, you use, well, I don't know if you use it less maybe, but basically the idea is finding anomalies. If something again, or maybe some people group by different, maybe again market segmentation again, to see maybe something interesting, right? And you can see different algorithms used. K-means, there's also bisecting K-means, very similar, right? So it says up to 50 or 100 segments, right? Limits, up to 10 million, right? Clusters, I think, no limit for training exams. So actually pretty big, right? So actually pretty again, pretty big variety of data you can use. Okay, what I do want to from you will be maybe less theory, more practical challenge. So to do, I have prepared for you data to do segment. I will add it here to our data, or CSV, I believe, yeah. I think you can just download it directly. I think it will work. I think it should work directly without this, without the folder. I think you can load it again directly. I think it should work, right? Let's see. And let me see here. Where is my data? There you go. Cluster. I made special data for you. Come on. Yes, refactor. Okay, add. So something very simple, just 60 data points, right? And maybe I should have made more. Actually, maybe I might add even a little bit more in this, but again, the idea will be the name will remain the same, right? The name will remain the same, right? So cluster this. Right, cluster me. So that will be your chance to do segment. Find optimal number of segments in the source resources CSV cluster me CSV file. It will be interesting challenge, right? So use silhouette calculations, right? So it'll be interesting to see, right? It should be pretty obvious, right? So and again, and then of course show, right, on print create show the optimal, show the data frame with these optimal segments, right? So so again, so the K could be again, so So to make it easier for you, k will be in range from 2 to, I don't know, 2, say 30, 20, right? 20, right? Nothing too big. So that will be your challenge. I think I'll make it a little bigger, the file, but it will be very similar. Okay, so that's your task, and I think it will be very interesting, and we will meet tomorrow, right? We'll meet tomorrow at 10, and we can see how well you did.